Today I'm going to tell you about what is Kubernetes. Kubernetes is a software that automatically manages, scale, and maintains multi-container workload in desired state. Modern softwares is increasingly run as fleets of containers, sometimes called microservices. A complete application may comprise many containers, all needing to work together in a specific way. Kubernetes is a software that turns a collection of physical or virtual host servers into a platform that hosts containerized workload, providing them with compute, storage, and network resources, and automatically manages large number of containerized applications, keeping them healthy and available by adapting to change and challenges. So, how Kubernetes work? When developers create a multi-containerized application, they plan out how all the parts fit and work together, how many of each component should run, and roughly what should happen when challenges. Example, lot of user login at a same time or encountered. They store their containerized application component in a containerized container registry, local or remote, and capture this thinking in one of several text files comprising configuration. To start the application, they apply the configuration to Kubernetes. Kubernetes' job is to evaluate and implement this configuration and maintain it until told otherwise. It analyzes the configuration, aligning its requirement with those of all the other application configuration running on the system. Find resources appropriate of running the new containers. Example, some containers might need resources like GPUs that are not present on every host. Grabs container images from the registry, start up the new containers, and help them connect to the one another and to the system resources. Example, persistent storage. So the application work as a whole. Then Kubernetes monitors everything, and when real event diverges from the desired state, Kubernetes try to fix things and adapt. For example, if a container crashes, Kubernetes restarts it. If an underlying server fails, Kubernetes finds resources elsewhere to run the container that node was hosting. If traffic to an application suddenly spike, Kubernetes can scale out container to handle the additional load. In in conformance to rules and limit state in configuration. Why we use Kubernetes? Uh, One of the benefit of Kubernetes is that it make building and running complex application much simpler. Where handful of many Kubernetes features, standard services like local DNS and basic load balancing that most application need and are easy to use. Standard behavior example, restart the container if it dies, that are easy to invoke and do most of the work of keeping application running, available and performant. A standard set of abstract objects called things like ports, replicates, and deployment that wrap around containers and make it easy to build configuration around collection of containers. A standard API is that application can call to easily enable more sophisticated behaviors, making it much easier to create applications that manage other applications. The simple answer to what is Kubernetes used for is that it saves developers and operators a great deal of time and effort and let them focus on building features for their application instead of figuring out and implementing way to keep their application running at scale. By keeping application running and despite challenges, example failed server, crash containers, traffic spike, etc. Kubernetes also reduce business impacts, reduce the need for fire drills to bring broke application back online, and protect against other liabilities like the cost of failing to comply with service level agreement SLAs. Where can I run Kubernetes? Kubernetes also run almost everywhere on wide range of Linux operating systems. Work nodes can also run on Windows Server. A single Kubernetes cluster can span hundreds of bare metal or virtual machines in data center, private or any public cloud. Kubernetes can also run on developers desktop, edge server, microservices like Raspberry Pi or very small mobile or IoT device and appliances. With some forethought and the right product and architectural choice, Kubernetes can even provide a functionally consistent platform across all these infrastructures. This means that application and configuration composed and initially tested on a desktop, Kubernetes can move seamlessly and quickly to more formal testing, large scale production, edge or IoT deployments. In principle, this means that enterprises and organizations can build hybrid and multi-cloud across a range of platforms quickly and economically, solving capacity problem without lock-in. What is Kubernetes cluster? The K8's architecture is relatively simple. You never interact interact directly with the nodes hosting your application, but only with the control panel, which present an API and is in charge of schedule, scheduling and replicating group of containers name pods. kubectl is the command line interface that allow you to interact with the API to share the desired application state or gather detailed information on the infrastructure's current state. Let's look at the various pieces nodes. Each node that hosts part of your dis- di- distributed application does so by leveraging Docker or a similar container technology such as Rocket from Core OS. The node also run two additional pieces of software kubeproxy which give access to your running app and kubelet which receive command from the K8's control panel. Node can also run Flannel and etcd backed network fabric for containers. Master. The control panel itself run the API server. Cube API server, the scheduler. Cube scheduler, the controller manages Cube controller manager, and etcd, a highly available key value store for shared configuration and service discovered. Implementing the raft conscience algorithm. What is enterprise Kubernetes? Kubernetes, by its provides a core software framework for container and resource management, default services, plus an API. It engineered to be extensive via standard interface to provide important capabilities like running containers, a container run time or engine, letting containers communicate, a container network, providing persistent storage, a container storage solution, routing inbound traffic to containers in a secure and orderly way, and ingress solution, full feature load balancer, distributing inbound traffic evenly to containers workload via int- integration with external load balancing solution, and many other components essential for efficient use and operation at scale. To make Kubernetes work at all, you or someone else need to choose and integrate solution to fill these critical slots. Kubernetes alternate made available free of charge. Typically select from among open source alternatives to provide these capabilities. These are often very good solution for learning and small scale use. Organizations that want to use Kubernetes to run production software at scale need more and more mature functionality. They need Kubernetes that feature complete, hardened, and secure, easily integrated with centralized IT resources like directory services, monitoring and observability, notifications and ticketing, and so on. They need Kubernetes that can be deployed, scaled, managed, and updated in consistent way, perhaps across many different kind of infrastructures. They need all the different part of Kubernetes to be validated together and supported by a single vendor. Enterprise Kubernetes refers to produce and suites of products that answer these needs, that fill all the Kubernetes feature slots with best of breed solution, solve problem of Kubernetes management across multiple infrastructure, enables consistency and provide complete support. So Kubernetes basic modules, creating a Kubernetes cluster, deploying an app, explore your app, explore your app publicly, scale up your app, update your app. So for more updates, please continue with us. Thanks. More will be updated in the next video. Thank you.